Well, good morning, everyone. We are in chapter 10, and we are looking at the problem set for section 10.2, and we're looking at the relationships between liters and moles and grams and liters when it has to do with gases at STP. And as a reminder, our constant, 1 mole of any gas at STP is equal to 22.4 liters. So 22.4 liters will be key here in this set. All right, so let's dig right in. Question number 1. How many moles are in 3 liters of hydrogen gas at STP? So we have our 3 liters of gas. Doesn't matter that it's hydrogen or carbon dioxide or carbon monoxide. Any gas at STP is going to be equal to 22.4 liters. So I gave you 3. Our constant is 22.4 liters. So that goes on the bottom of the division problem. And so our final, now I'm going to ignore rounding conventions, significant digits here. And I'm going to give you 0.13 moles as an answer. 0.13 moles. Some of you may have 0.134. That's just fine. All right, and let's go down to the next one. How many moles are there in 0.5 liters of O2 at STP? So I'm giving you 0.5 liters. Our constant is 22.4 liters per mole. Liters per mole, that's a little confusing, but I think you know where I'm going. When you do that math, you wind up with 0.02 moles of oxygen at STP. And again, the confusion here, this is strictly the units. Liters per mole, I could have done liters times moles to the -1, the inverse, but we didn't do that. And to avoid confusion, I think I will just not use that convention here. All right, if I'm given 10 liters of any gas at STP, how many do we have? Giving you 10 liters, dividing by our constant of 22.4, and I'm just going to say it, liters per mole, and that gives us a result of 0.45 moles. So these are pretty simple. Take what you're given in the problem, your constant's 22.4 liters per mole, and away you go. All right, how many moles do we have? 300 liters. Give me 300 liters divided by 22.4 liters per mole of carbon dioxide, and our answer is 13.4 moles. Question number 5. If you are given 20 liters of nitric oxide at STP, how many moles do you have? Our math, again, this is just all good practice. I know that the same, you may have gotten bored. So we've got 20 liters. Our constant is 22.4 liters per mole. And then our final result is 0.9 moles. And then let's raise this up a little bit for our next five questions here. Next 5 questions. All right, that looks like we're in good alignment. Good alignment here. Number 6. Number 6 is same path. giving you 150 liters of any gas, 150 liters divided by our constant, 22.4 liters per mole, and our result there is 6.7 moles. All right, now we're changing up a little bit. I'm giving you grams of gas now, grams of gas. So it's really a two-step problem. We've got to convert the grams to moles, and then from moles to liters. So let's take this slowly. We have 90 grams of carbon dioxide, but we need to know what the molar mass is. And just as a bit of review, we have one atom of carbon at 12 grams per mole. And in carbon dioxide, there's only one mole or one atom. So we just have 12 grams worth of carbon. And then dioxide, oxygen, we have O2, and that's, as we know, 16 grams per mole for oxygen, but we have two. So 2 atoms, it's going to be equal to 32 grams worth of oxygen. Add those up together, and let's go back here. We're going to add those two up together. So 12 plus 32 is equal to 44 grams per mole CO2. All right, so that's our first step. We need a little bit of break here, just a second. Let me go into here. See if we can make a quick change. There we go. All right, got a little bit more space to work with. Okay. Changes here. All right, so let's continue with the problem here. All right, so we figured out that 1 mole of carbon dioxide is 44 grams per mole. I'm giving you 90 grams. And need to divide that by 44 grams per mole. And again, I'm going to leave that mole off so it just is not confusing. That's going to be equal to, so how many moles do I have? 2.045 moles of CO2. So that's how many moles I have. And so then we need to take our convention of 22 grams, 22.4 liters per mole. We're going to multiply this out. And when we multiply our 2.045 times 22.4, we come up with 1,344 liters. We're working in liters now. So just to take a little review, we calculated that we had 2.045 moles of CO2. Each mole is, well, let's back the truck up. We've got a little bit of a math error here. I'm looking at the next problem. It's a good thing. 13.44 is the answer for the next problem. So 2.045 times 22.4 is going to give us 45.8 moles of liters. I'm losing it here. I need a little more coffee. Let's take a 5-second coffee break here. So our final answer there was 45.8 liters of gas at STP. All right, sorry for the pause, needed a little coffee. All right, next problem. So we've got 120 grams of H2. How many liters? So it's the same path. H2 is 2 atoms of hydrogen. So that's 2 grams per mole. So I'm giving you 122 grams of hydrogen, and it's 2 grams per mole. So that's going to give us 60 moles of H2 gas. All right, and each mole occupies 22.4 liters. And so that's where our 1344 comes from. Gives us a total of 1,344 liters of hydrogen. A lot of hydrogen gas. A lot of hydrogen gas. All right, let's bump this up real quick since I used some. All right, that's gonna be tight, but it should work. It should work just fine. All right, back to typing here. And all right, now, all right, working a different way. I've got 10 liters of H2 gas at STP. How many grams do I have? All right, so I'm giving you 10 liters. It is 22.4 moles per liter, and so that is a total of 0.45 moles of H2 gas. And we know that each mole of H2 is 2 grams per mole, 2 grams per mole, for a grand total of not a whole lot of hydrogen gas, 0.9 grams of H2 in that problem. All right, and then finally, let's see if this works. Yeah, we do have the line. We've got 5 liters of CO2 at STP. So I've got my 5 liters, divide that by my constant of 22.4 liters per mole. And so that gives me 5 liters times divided by 22. Don't like my math on this. Yeah, I do like my math on this. 0.22 moles gives me 0.22 moles. And then finally, if we look back up here, our carbon dioxide in problem 7, 44 grams per mole times 44 grams per mole. And that's going to give us a grand total of 9.7 grams of carbon dioxide. All right, well, I hope you enjoyed working through that set of 10 problems. Again, we do multiple practices of each one so that you really get this down. And so until next time, I hope you are having a great day.